today what we're going to be doing is continuing Chapter 7, Section 2, Inverse Functions and Relations. So right now, we need to find this function's inverse. And our final answer is going to look like this. F to the negative 1 of x is going to equal something. And we're going to solve for that. So right now, what I'm going to do is I'm going to write y equals 1/4 x minus 2. Now I know it's been a whole day, but what would be the first thing that I'm going to do to solve for its inverse? Switch x and y. All right, let's do it. Switch the x and the y variables. Now, after we switch the x and the y variables, now we simply have to solve for y. Okay? So what would be the first thing I would have to do to solve for y? Add 2. Add 2 to this side. And add 2 to this side. All right, bless you. And x plus 2 is just x plus 2. And that equals to 1/4 of y. Now, we don't want to know what 1/4 of y is equal to. We want to know what y is equal to. So what could I do to both sides? Some of you might think, oh, I'm going to divide both sides by a 4. But I would say, let's multiply both sides by its reciprocal, which is 4/1, right? But instead of writing 4/1 right here, I'm just going to write the number 4. Okay? 1/4 times 4/1, they totally cancel out. And then I just have to distribute the 4 to the x and distribute the 4 to the 2. So here's what you're left with. Y equals 4x plus 8. That is the inverse of your original f of x function. All right, so what we're going to do is right up here for f to the negative 1 of x, or the inverse, you're going to write 4x plus 8. And this right here is your final answer for the inverse of this function. Okay? Now we're going to graph it. Okay, we're going to graph this one, and we're going to graph this one. All right, so I'm going to go down to the graph area right here. I'm going to make 2 tables, okay? The first table is going to be for the y equals 1/4 x minus 2. And the other table is going to be for the y equals 4x plus 8. Okay? So we'll make a little table. X and y. X and y. All right. We're going to start with the easiest number right over here. We're going to plug in a 0. When you plug in a 0, you get a negative 2. So I'm going to go 0, negative 2. I'm going to put a point right there. Now the cool thing about this, knowing that this is the inverse, if I plug in a negative 2 here, that should be a 0. 0, negative 2, negative 2, 0. Does it work if I plug in a negative 2 right there? 4 times negative 2 is a negative 8. What's negative 8 plus 8? 0. It works. Cool. All right. How about this? What if I plug in, I don't know, let's go up 1 over 1, 2, 3, 4. All right, there's a point right here. That's a fourth slope, up 1 over 4. So my ordered pair is a 4 and a negative 1. 4 and a negative 1. I bet if we plugged in a negative 1 here, it would become a positive 4. Let's check. If I plug in a negative 1 right there. 4 times negative 1 is negative 4, plus 8 is 4. That one works too. All right. So right now I have that. Let's go down 1 and over 4 to the left right here. What is this ordered pair? This ordered pair is a negative 4, negative 3, right? Negative 4, negative 3. If I plug in a negative 3 right here, I plug in a negative 3. 4 times negative 3 is negative 12. Negative 12 plus 8 is a negative 4. It looks like these will be actual inverses of each other. So now I'm going to make my line nice and straight as best as I can through those points right there. You do a very good job. we go. There's that line. One more time. There we go. There's that line. Now let's plot my other points in red. One of them was at a what? -2, 0. Then I had a -1 and a +4, and then I had a -3 and a -4 right there. So I'm going to make a line going through that. Here, go straight down. Now, what did I say yesterday that inverses and their functions, their relations to functions, what do they reflect across? Yeah, they reflect across what? Y equals x. So what I'm going to do is I'm going to draw in the graph y equals x, and let's see if they actually reflect across them. All right? So up one, over one, up one, over one, up one, over one, up one. Start here. I'm going to go straight through the origin. Wow, they do. This point reflects perfectly across. This point reflects perfectly across. This point reflects perfectly across. This is the graph y equals x, and these are perfectly reflected across each other. So the first part of the problem, I asked you to find its inverse. The second part of the problem, I asked you to graph the function, the original function, and then graph its inverse. And that's what you're going to be doing on problems 5, 6, and 7. This is problem number 7. All right, problem number 9. We're going to check to see if these two functions are actually inverses of each other. Okay? So I'm going to highlight this one in blue. I'm going to highlight this one in red. We're going to see if these are actually inverses of each other. Now you'll notice up here, I'm going to highlight this, if f of g of x equals x, or right here it says, and if g of f of x is equal to x, then they are indeed inverses of each other. So what I'm going to do right now is I'm going to write f of g of x equals the same thing as saying f of g of x. Now what is f of x by itself equal to? F of x by itself is equal to a -4 times x plus 1. What we're going to do is we're not going to find f of x. We already know what it's equal to. We're going to find f of g of x. So I'm going to put a -4. I'm going to put a big old parentheses and put plus a 1. And I want you to look at what I need to plug in for my value of x. So instead of plugging in an x, where there's an x, what am I going to plug in? I'm going to plug in g of x. Now, what is g of x equal to? All of this, 1/4 times the difference between a 1 and an x. So right here we're going to plug in 1/4 times 1 minus x, close parentheses. So I'm taking g of x and I'm plugging it in for the value of x. That's how you do f of g of x. Okay, now that I've taken the red function and I've plugged it into the blue function, now we need to evaluate all of this. So we're going to evaluate what is f of g of x equal to. So I have a -4. I'm just going to do everything in the same color right now just so it's hopefully easier to see. 1/4 of 1 minus x, close parentheses, plus 1. So whenever you guys are working with parentheses, you work on the innermost parentheses and you work your way out. So can I combine the 1 minus x? No, can't. They're not like terms. But I can multiply what? A 4th times the 1 and a 4th times the negative x. So here's what that would be. We have a -4. We're going to open up the parentheses. What is a 4th times 1? 1/4. 4 times 1 is 1/4. What is a 4th times a negative x? Right. -1/4 x plus 1. So right now I've simply evaluated everything inside of this parentheses. That's all I've done. So far so good?
Yeah.
Now I'm going to take a negative 4 and multiply it to a 4. And then the negative 4 and multiply it to a negative 4. What is a negative 4 times a 1/4? That's a negative 1. A negative times a negative is going to be a positive. And what is 4 times a 4th? What's a quarter of 4? 1. So a negative 4 times a negative 1/4 x simply equals the value of x. And over at the very end, I'm going to put plus 1, because there's a plus 1 at the end. Well, what is negative 1 plus 1? 0. So what did f of g of x ended up equaling? X. Well, whenever f of g of x equals x, that lets you know that these functions are indeed inverses of each other. So you could say, your answer would be yes, comma, they are inverses. Okay? Yes, they are inverses. Now, since we're doing this in your journal, we're also going to be doing g of f of x. All right? So I'm going to clear everything out. I'll go back. All right, so we're going to highlight this real quick. We're going to highlight this in blue. We're going to highlight this in red. This time, though, everybody, we're going to find g of f. Go back to the g of f of x, which is g of f of x. All right, so let's look at this one. We have g of x, which is equal to 1/4 parentheses 1 minus x close parentheses. That's what we have. However, this time we are going to take the blue function and we're going to plug it in to the red function. So this time it's going to look a little different. So I still have a 1/4. I've got a 1. I've got a minus. But now I'm going to open up a big old parentheses right here. I'm going to close it out. And what am I going to plug in right in here? What am I going to plug in for my value of x? I'm going to plug in what? F of x, right? And what is f of x equal to? Negative 4x plus 1. So I'm going to write all of this in one color now. Here we go. Equals 1/4, open parentheses, 1 minus, open parentheses, negative 4x plus 1, close parentheses, close parentheses. You guys see this negative right here? I need to multiply that negative to this negative and this negative to that 1. So I have a 1/4. I have a 1. What's a negative times a negative? Positive. So I'm going to put plus 4x. What's a negative times a positive 1? That's going to make that a negative 1. I've got a 1 and I've got a negative 1. What's going to happen to that 1 and that negative 1? They're going to cancel each other out, right? What am I only left with? 4x, because 1 minus 1, those cancel out to 0. Well, what is a fourth of 4x? 1 what? 1x. So what did g of f of x end up also becoming? X. By the way, do you know what line inverses always reflect across? What line? No. Y equals x. It always reflects across y equals x. So if you take one function and you plug it into the other function, and all you get is an x, that lets you know that what? They are inverses of each other.